In 9.1, we studied about sequences, right? We talked about a convergent sequence and a divergent sequence. In 9.2, we are going to study about series, and we are going to talk about the convergence or divergence of a series. Alright guys, infinite series, meaning we start at n equals 1 and go all the way up to infinity. Now series is denoted by the summation sign. Summation sign means you add up all the terms, right? And you may recall that in a sequence, the terms are separated by commas, a1, comma, a2, comma, a3, comma, so on and so forth. But in a series, the terms are separated by a plus sign. Why? Because in a series, we are adding up all the terms. We want to find the total. Okay guys, in an infinite series, we will start with a1 first term and go all the way to an and go beyond an. Okay, so what is S1? S1 is the sum of the first term, in other words, the first term itself. S2 stands for the sum of the first two terms. So S2 is the sum of the first two terms, a1 plus a2. S3 is the sum of the first three terms, a1 plus a2 plus a3. That's how you find the sum, the finite sum, okay? Because these are, you can easily add these numbers, right? First and the second, first, second, third, so on and so forth. Okay, definitions of convergent and divergent series. For the infinite series, the nth partial sum is given by that. Alright guys, it's very easy to understand. Sum means you add up all the terms. The nth partial sum means you add up the first n terms. Okay? So this is the definition of the nth partial sum. If the sequence of partial sums converges to S, then the series converges. Basically guys, if Sn converges to a finite number, then the series converges. The limit S is called the sum of the series. Alright guys, so one of the ways to determine convergence or divergence of a series is to look at the nth partial sum. Nth partial sum is obtained by adding up the first n terms of the series. Okay, if the sequence of partial sums converges, then the series converges. The limit S is called the sum of the series. Now, if the sequence of partial sums diverges, then the series diverges. Alright, as you study this chapter, you will see that there are two basic questions involving infinite series. Does a series converge or does it diverge? When a series converges, what is its sum? These questions are not always easy to answer, especially the second question. When a series converges, what is its sum? Okay? Guys, let's have a look at this. So, thus far, guys, we only know one way to determine convergence or divergence of a series, right? And that is to look at the nth partial sum. So, you know what that says? If the nth partial sum converges to a finite number, then the series converges and S is called the sum of the series. Okay? If the nth partial sum diverges, then the series diverges. Let's apply the nth partial sum test on this infinite series. Alright guys, if you were to keep on listing the terms, the first term is 1 over 2. The second term is 1 over 2 squared. Third term is 1 over 2 cubed. Fourth term, 1 over 2 to the power 6. Okay? So what is the first sum? That's 1/2. What is the second sum? 1/2 plus 1/4. What is the third sum? 1/2 plus 1/4 plus 1/8. Right guys, you know that 1/2 plus a fourth is 3/4. This plus this is 7/8 and so on and so forth. So guys, are you seeing a pattern here? So guys, if we continued in this way, what is the formula for Sn? Okay, have a look. Sn is going to be 1/2 plus 1/4 plus 1/8. That's the third term. The fourth term, fifth term, sixth term, all the way up to the nth term. What's the nth term of the series? 1 over 2 to the n. Now guys, are you able to see a pattern here? Look here. For the first term, for the first sum rather, denominator is 2. For the second sum, denominator is 4. For the third sum, denominator is 8. So the denominators are all powers of 2. So for the nth sum, it's going to be 2 to the power n in the denominator. And also notice the numerator in each case is 1 less than the denominator. So in the nth partial sum, the numerator is 2 to the power n minus 1. So that is the formula for the nth partial sum. Now what does the nth partial sum test say? You have to go ahead and find the limit as n goes to infinity of Sn. That is limit as n goes to infinity of 2 to the n minus 1 over 2 to the n. Okay? So guys, have a look at this. How do you rewrite this in order to find the limit? And you may notice that guys, as n goes to infinity, both top and the bottom are going to go to infinity, right? So you have to apply L'Hopital's rule many times, but have a look at this. This is going to be same as, let me divide everywhere by 2 to the n. Okay, basically guys, I'm simplifying the fraction. Now what do you get as a result of the simplification? Limit as n goes to infinity of 1 minus 1 over 2 to the n. Now what is that limit? Limit of 1 is 1, and limit of that 1 over infinity is 0, so that limit is 1. Okay guys, so what we have done here is we have taken the limit as n goes to infinity of the nth partial sum. Now nth partial sum was not given in the question. We established the nth partial sum. This was not given in the question. We established by listing the first 3 partial sums and observing a pattern. That is the limit of the nth partial sum. Okay? Now, so the limit of the nth partial sum is 1. So we say the series converges, because 1 is a finite number. The series converges and its sum is 1. Okay? Alright, so that is one way to test convergence or divergence of a series. Remember, we are talking about series now. Alright guys, have a look at this one here. Let's try and determine the convergence or divergence of this by using the nth partial sum test. Okay, let me start with S1. S1 is the sum of the first term, which is the first term itself. 1 over 1 is 1, 1 over 1 plus 1, that's 1 half. S2 is going to be the sum of the first 2 terms. I know the first term is that, plus what's the second term? 1 over 2 minus 1 over 2 plus 1. Okay, S3 is going to be the sum of the first 3 terms. Here is your first term, here is your second. What's the third one? 1 over 3 minus 1 over 4. Alright guys, so in that manner you will go ahead and establish Sn. Remember, Sn is not given in the question. You have to establish that first. Sn is the sum of the first n terms. So here is our first, plus here is our second, then you have your third, and then you have your fourth. You get the pattern, don't you? Then you have your fourth plus a whole bunch of terms, and you go all the way up to the nth term. So what is Sn going to be? Okay, negative 1 half, positive 1 half gone. Negative 1/3, positive 1/3 gone. So guys, likewise, everything will be gone, leaving us with the 1 here, which is not going to go anywhere. And the last term, negative 1 over n plus 1. Okay, leaving us with this term and the last term. All the middle terms will be cancelled somehow. Okay, so this is what we call a telescoping series. Alright guys, so now we have established what Sn is. We want to find the limit as n goes to infinity of Sn, right? How do you find that limit? That's right, limit as n goes to infinity of Sn. That will be limit as n goes to infinity of 1 minus 1 over n plus 1. Limit of 1 is 1, limit of the second term is 0. So the limit of the nth partial sum, guys, as n goes to infinity is 1, which is a finite number. So because the limit of the nth partial sum is a finite number, we say the series, the infinite series given in the problem, converges and its sum is 1. The sum is given by the limit. Alright, now have a look at the next one. You may be able to figure this out very easily. Let's go ahead and determine convergence or divergence of this by using the nth partial sum. First term is 1. Second term is, hey guys, you know what this means? No matter what n is, the terms are always 1. So the second term is also 1. So the second partial sum is first term plus the second term. Third partial sum is first term plus the second term plus the third term. So you know what's happening, right? Now can you tell me what the nth partial sum is? Okay, go all the way down. So nth partial sum, how many times are you going to write 1? You're going to write it n times 1, which is n. Okay, so now go ahead and find the limit of the nth partial sum. Okay, so we have limit as n goes to infinity of Sn, which is limit as n goes to infinity of n, because the nth partial sum is n, and that number is going to be infinity. And because the limit of the nth partial sum is not a finite number, it's an infinite number, we say the series diverges. Okay guys, if it diverges, the sum is infinity, right? Right, I just want to talk about the telescoping series a bit more. I just showed you a case of a telescoping series. So guys, the B2 is cancelled by the second term, B3 is cancelled by the third term, and so on. And the nth partial sum is B1 minus that. It follows that a telescoping series will converge if and only if Bn approaches a finite number as n goes to infinity. Moreover, if the series converges, then its sum is given by that. Okay, you don't have to memorize that. You go ahead and find Sn, and while trying to figure out a formula for Sn, you will realize that it's a telescoping series, and then find the limit as n goes to infinity of the remaining terms of the telescoping series. Alright, next one. Write a series in telescoping form. So guys, before you go ahead and write this in telescoping form, you need to make sure that the terms go as plus minus, right? So that they can get cancelled. So in order to do that, what we are going to do is, we are going to make use of partial fractions. Let's go ahead and factor this. That's 2n plus 1 times 2n minus 1. Okay, so we have a lot of work to do. So I'm going to consider the fraction 2 over 2n minus 1 times 2n plus 1. We are going to decompose this into partial fractions. Notice that the denominator has two distinct linear factors. It can be a constant over the first factor plus a constant over the second factor. Okay, take the common denominator. Why? Because we are trying to solve for a and b. So you have a over 2n plus 1, a times 2n plus 1 plus b times 2n minus 1. Notice that the denominators are the same. You have an equal sign in between. The numerator 2 must equal the numerator here. Okay? So guys, you now have to solve for constants a and b. Alright, so you can do that by comparing coefficients. Okay guys, compare coefficients. Okay guys, what's the constant here? Constant here is 2. What's the constant? A minus b. Okay? Now, what is the coefficient of n? Okay guys, here I equated the constant. Here I'll equate the coefficient of n. There's no n here. The coefficient of n here is 2a, and the coefficient of n there is 2b. Alright guys, so from the first term, I can say a is 2 plus b. I'm going to use the substitution method. Come here, replace a by 2 plus b. So what do you have? You have 4 plus 2b plus 2b. So 4b is negative 4. You will get that b is negative 1. Now if b is negative 1, a should be 1. Okay? So now let's write what we have in terms of partial fractions. So guys, our original problem was this infinite series. Now we are broken down into two partial fractions. The fractions are a over 2n minus 1 plus b. b is negative 1 over 2n plus 1. Okay? Now, Sn, the nth partial sum, is not given. Can you go ahead and establish Sn at the first term, to the second term, to the third term, all the way up to the nth term? What's the first term? 1 over 2 minus 1, 1 over 2 plus 1. What's the second term? 4 minus 1 is 3, 4 plus 1 is 5. Third term, 6 minus 1 is 5, and 6 plus 1 is 7. It keeps on going until the nth term, 1 over 2 minus 1 minus 1 over 2 plus 1. Hey guys, the nth partial sum goes all the way up to the nth term. Okay, so what do you notice when you try to find Sn? Negative 1/3 gone with positive 1/3, negative 5/5 gone with that. So guess what you will notice is that Sn will be equal to 1 minus the last term here. Okay? Now, to determine convergence or divergence, we have to find the limit as n goes to infinity of Sn. That is limit as n goes to infinity of 1 minus 1 over 2n plus 1. As n goes to limit of 1 is 1, as n goes to infinity, 1 over infinity is 0, which is 1. So, the limit of the nth partial sum is a finite number 1, so I would say the series converges and its sum is 1. Alright, that's one way to determine convergence or divergence of an infinite series. Alright guys, we have a special series coming up next, and that is called the geometric series. Okay. Next one is the geometric series. Alright, geometric series is of this special form. Sigma n equals 0 to infinity a times r to the power n. A times r to the power n. Hey guys, this a here is the first term. Okay, now look, the geometric series here starts with n equals 0, not n equals 1. When n is 0, r to the power 0 is 1. 1 times a is a. When n is 1, it's ar. When n is 2, it's ar squared, so on and so forth. So guys, the geometric series is generated by multiplying each term by r, starting from the first term. A times r is ar times r is ar squared, so on and so forth. So guys, it's very easy to identify a geometric series. It has to be of the form sigma n equals 0 to infinity a times r to the n. Please study that special form. Okay, and r is known as the common ratio. Okay, so I would write common ratio. The number that you're multiplying by each time is called the common ratio. That's a constant number. Alright guys, here is an important result. A geometric series with ratio r diverges when the absolute value of r is bigger than or equal to 1, and if the absolute value of r is between 0 and 1, then the series converges. Okay, now if it converges, the sum of a geometric series is given by a over 1 minus r. If it diverges, you don't apply this formula. When does it converge? It converges when the absolute value of r is between 0 and 1. In other words, when it's less than 1. Okay? Determine the convergence or divergence of the geometric series. If the series converges, find its sum. Alright guys, what does this look like? 3 over 2 to the 0. 2 to the 0 is 1, so that's 3. And then 3 halves. Right guys? What else? 3 over 2 squared, 3 fourths. 3 over 2 cubed, 3 eighths. An infinite geometric series. So you guys look at this special form. The special form here matches the special form. Do you guys agree? N is starting at 0, going all the way up to infinity. A times r to the n. What is a here? What's the first term? First term is 3. And what is r? What are we multiplying by each term? You know what we are multiplying by? We are multiplying by 1/2 each time. Okay? So absolute value of r is 1/2, which is less than 1. And what does the result say? If the absolute value of r is less than 1, the series converges. Okay? The series converges. Okay? And its sum is s equals a over 1 minus r, 3 over 1 minus a half, 3 over half is 6. The series converges and its sum is 6. Hey guys, another thing is, if you have trouble coming up with a and r, why don't you rewrite it like this? Let me show you. So the question says sigma n equals 0 to infinity, 3 over 2 to the n. So can we rewrite this as 3 times, how do you rewrite this? 1 over 2 to the n, isn't that 1/2 to the power n? Okay, so that clearly shows you a is 3, r is 1/2. Okay, you can come up with r that way. So right, we can do that. Okay, figure out a is 3, figure out r each time you're multiplying by 1/2. Absolute value of r is 1/2, which is less than 1, so the series converges and its sum is a over 1 minus r. Guys, please study this up. A geometric series with common ratio r diverges if the absolute value of r is bigger than or equal to 1. If the absolute value of r is less than 1, then the series converges and the sum is a over 1 minus r. First term over 1 minus common ratio. Okay. Guys, you don't even have to list the terms. Isn't this same as, guys, you want to put it in the form a times r to the n. You see an invisible number. That is your a, r to the n. A is 1, r is 3 halves. Okay, so what can you say about the absolute value of r? So, absolute value of r is 3 halves, which is bigger than or equal to 1. And it's a very simple test, guys. We will say the series, the geometric series, diverges. In other words, it has an infinite sum. It does not have a finite sum. Okay. What's the usefulness of a geometric series? Guys, we can use a geometric series to write a repeating decimal in terms of a fraction. Alright guys, what you see here is a repeating decimal, also known as a recurring decimal. 0.08 with a bar on top of 0.8. What does that mean? That means 0.08, 08, 08, 08. It's going on like that indefinitely. Okay, how can we generate this? By adding numbers. Let's start with 0.08. To that add 0.0008. To that add 0.000008. So on and so forth, so that you can keep on generating that list. So guys, if you look here, we can write 0.08 with a bar as, first start with 0.08. And what is 0.08? That is 8 over 100. Okay, to that add 8 over 10,000, right guys? 8 over 10,000. To that add 8 over 1, 2, 3, 4, 5, 6, 6 zeros. That's going to be 1 million. So on and so forth. Look at this sum. Don't you think they're generated by a geometric series? What is the first term here? First term is 8 over 100. What is the common ratio? What number are you multiplying by each time to generate the next? Aren't you multiplying by 1 over 100 each time? Each time you're multiplying by 1 over 100. Okay? So what I'm going to do is I'm going to write 0.08 with a bar as a geometric series. Geometric series starts with n equals 0, goes up to infinity, ar to the power n. I'm going to fill in n equals 0 to infinity, a is 8 over 100, r is 1 over 100, raise it to the power n. Okay? Now look guys, absolute value of r is still 1 over 100, which is less than 1. So the series converges. If it converges, we can find the sum using the formula a over 1 minus r. A is 8 over 100 over 1 minus the common ratio is 1 over 100, which is 8 over 100 over 99 over 100. The 100s cancel, you get 8 over 99. Now, take your calculator right this minute, plug in 8 divided by 99 to make sure that you get this recurring decimal 0.08080808. Alright guys, the other thing I want you to note here is that the convergence of a series is not affected by the removal of a finite number of terms from the beginning of the series. For example, these two geometric series converge. They both converge. Okay? Now, because the sum of the seconds, what's the sum of the second series, guys? What is the sum of the second series? Is s equals a over 1 minus r. What is a? A is the invisible number 1. 1 minus r is 1/2. 1 minus 1/2 is 2. Because the sum of the second series is 2, use that to find the sum of the first series. Now look guys, the second series has more terms than the first series because the first series is starting at 4, whereas the second series is starting at 0. So it has more terms. N equals 0, n equals 1, n equals 2, n equals 3. It has 4 more terms. So to find the sum of the first series, in other words the smallest series, all we have to do is take the sum of the bigger series, which is 2, take away the 4 terms that are not here. When n equals 0, that is not there. When n equals 1, when n equals 2, and when n equals 3. That's going to be 2 minus 15 over 8. So the total of the first series starting at n equals 4 is 1/8. Okay, you find the sum of the larger series and take away the terms that are not in the first series to find the sum of the first series.